good to go now. All right. All right. Probability of A given B is 0.4. Probability of B is 0.7. Probability of A not given not B is 0.2. Okay. Boy, this one is it's weird how they give this to you. A given B. Okay, so it's like you go down a path and you get to let me jump back up here, do this a little differently. So I don't quite know where to tell you to start yet on this, but you start somewhere and it says, okay, probability of A given B. So that means here's B and then you have a choice. Here's A. So this is A given B, and that's 0.4. The probability of B is 0.7, okay? And then the probability of A given not B, so here's not B over here. And we would assume that's 0.3 because there's these two paths have to make that. So A given not B means here's A, and that's 0.2. And then there's also these other paths which we haven't talked about. Probably of B given A. Okay. So there's also these other paths here, A naught and NA naught, and these would be 0.6 and 0.8. I think that's why it's just to draw a diagram. So the probability of B given A, well, there's two places where you can get an A. Okay, and to get to those two places, so to get to this first one, this first A, it's 0.7 times 0.4. So that's going down this path. Plus, to get to this A over here, it's 0.3 times 0.2. And then we choose the one we want. We actually just want the one where you get B, and that's this one here. So B given A is this path. Because you get a B here, it's a not B. So it's 0.7 times 0.4. And one of the things you'll see in almost all of these Bayes theorem questions is that whatever's on top will also be in the bottom in one of the positions. All right, so I really hope this is correct. And I'm going to multiply this out. If you're going to do this in your calculator, make sure you put parentheses around the bottom. Make sure you get those numbers there. Uh, 0.7 times 0.4 over 0.7 times plus 0.3 times 0.2. Okay. I'm getting. Oh, I multiplied. There it is. Okay. So I get this ends up being equal to 0.8235. Hopefully that's correct. And it is. Okay, so the hardest part is probably drawing the picture. Hopefully that's somewhat clearer now. So we'll go to question 3, because we already did question 2. Sorry, my screen, I didn't mean to make that not full screen. Come on. Okay, there we go. We get question 2 snipped in, or question 3, I'm sorry. And this one is, it's another Bayes theorem. They all are, but this one will maybe be clearer. I'm not sure. We'll draw a few of these trees because maybe it'll help. All right, so this one says, suppose that it snows in Greenland an average of once every 26 days. So we got snow and then not snow. And that's what this tick means. Once every 26 days, so 1 over 26. And then over here is 25 over 26, because those are days that does not snow. When it does, you have a 20% chance of glaciers. So glaciers, that's 0.22. And when it says when it does not snow, they only have a 5% chance. So the glaciers are over here, and that's 0.05. And then there's the G naught, and then the G naught, the not glaciers, and that's 0.78 because they got to add up to 1, 0.95 because it's got to add up to 1. Now we figure out what it's asking. What is the probability that it is snowing in Greenland when glaciers are growing? So we care about these two positions, but specifically we only care about this one on the left here where you got snow, but they're both possible. So the bottom is where they're both possible. That's the 1 over 26 times the 0.22 plus 25 over 26 times the 0.05. And like I mentioned before, one of these is going to go up in the top. It ends up being this one because this is the one where it says probably that it is snowing. So you just grab it, 1 over 26 times 0.22. Let me multiply this out. So when I do this calculation, get a little more room here, get 0.1497. So I'll try that. Okay, and that was correct. So let's move on to the next one here. These are all sort of the same. We'll probably add three scenarios in the next one. We'll see what we got here. All right, in a certain year, 45.3% of all light vehicles were cars, and the rest were pickups or SUVs. The probability of a side impact crash is given in this table here. Okay, so well, this is kind of a horrible question. So we got cars, and then they call it light truck or SUVs. So we'll just go I don't know, LTS for those. That's so the probability that it's a car is 0.453, and then the other ones is 1 minus that, so 0.547. Okay, now if you're in a car, the probability deadly. So deadly in a car, it's 1. So the probability that it's not deadly is 0, and then in LTS, deadly is 0.3, and then 0.7 is that it's not deadly. So you make the diagram and then you see what it's asking for. What is the probability that a victim of a deadly side impact crash, so that tells you which two you care about, those two down here, was driving cars? What's the probability that they were in a car? So again, on the bottom, it's going to be 0.453 times 1 plus 0.547 times 0.3. And you got to figure out which one goes up the top. Well, it's the fact that they were driving a car. So 0.453 times 1. All right, so the number I get here is 0.7341. We'll try that. All right, I'm going to move on to number 5. This one's also a little odd, but they're all diagram problems like we're doing, and if you can set up the diagram, you'll be in great shape. I mean, they won't change from these numbers. So all right, so this one says they got a professor that says all senior physics majors takes his notorious physics aptitude test. The test is so tough that anyone not going on to a career in physics has no hope of passing. Whereas 55% of the seniors who do go on to career in physics still fail the test. Furthermore, further 85% of all senior physics majors, in fact, go on to a career in physics. Assuming that you fail the test, what is the probability that you will not go on to a career in physics? This one's a little bit harder for me to actually figure out what to put as the kind of that first break. So there's career in physics, I guess. We'll start with that. Career in physics, that's 55%. And those that don't go on to a career in physics, that's 0.45. Physics majors, in fact, 85% of all physics majors, in fact, go on to a career in physics. So physics majors, that doesn't seem right. Okay, let me just delete that and see if we start. So we have this test, and the probability of passing the test. Fail the test. Okay, you go under current physics. Okay, I'm sorry. So I got the wrong numbers. Who do go on to current physics still fail the test. 55% still fail the test. So 45% pass the test. So we have this test. Okay, so there is kind of this physics career, and then there's not a career. So maybe we did have the right words. Let me see if I can get. I think I had the wrong numbers, but we had the right words. Yeah. Okay. So you had the right numbers, wrong words. So so you're a physics major. That's what's going on here. You're a physics major, and 85% go on to a career. That means that 15% do not go on to a career. And then it says 55% who do go on to a career in physics still fail the test. So we've got pass the test, fail the test, and we're saying that 55% fail, 45% pass. If you do not go on to a career in physics, that's the first line of this. That's where it's really a little bit awkward. It says if you don't go on to a career in physics, you are guaranteed to fail the test. You will never pass it. Okay, so the key here is figuring out, getting this chart down and knowing where these numbers go. So assuming that you fail the test, okay, and that tells you it's here and here, okay, what's the probability that you will not go on to a career in physics? So that's this one, this path over here. So the two that we care about are this 0.85 times 0.55 plus 0.15 times 1. And which of these two are they asking? Well, it says not go on to a career in physics. That's this one down the right. That's the 0.15 times 1. Sorry if that was confusing, because it was, it was confusing for me. And but we got that down. 0.2429. Let's see if it takes that. Great, and it did. Okay, 6, 7, 8. Okay, so 3 more questions. So sometimes it just feels like these just are endless, but they're moving on to more branches, more forks in for these problems. So question 6, we'll look at here. All right, in a year, 27.8% of all light vehicles were light trucks, 27.8% were SUVs, 44.4% were cars. So there's like 3 different categories that they're starting out with. We should check that these add up to 1. It looks like they do. So we got light truck LT, SUV, and car. So it's not always like car, not car. Sometimes it's other categories, 0.444. Now, the table here gives the probability that you would deadly in a, I can't believe they're doing this, in a crash again. So the probability in an LT of deadly is 0.21, and then D naught is 0.79. SUV, same thing. Probability of deadly is a 0.371, 0.629, deadly not. And then car, same thing. Deadly is 1, uh, and then not is 0 over here. Okay, so now what is the probability that the victim of a deadly side impact accident was driving an SUV? So the three places we care about: deadly, 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 but in particular we care about this one down this branch here because that's the SUV. Okay, so we got the first kind of transition down is 0.278, 0.21 plus 0.278. This times 0.371 plus 0.444 times 1. That's this last branch down here. And then the one we care about is this middle one, the 0.278 times 0.371. The tree really helps. I can't emphasize that enough. All right, so the number I get here for your answer is 0.1703. All right, move to question 7. All right, according to a study in a medical journal, 202 of a sample of 5,990 middle-aged men had developed diabetes. It was also found that men who were very active were a third as likely to develop diabetes as compared with men who were sedentary. Assume that 1/4 of all middle-aged men are very active and the rest are classified as sedentary. What is the probability that a middle-aged man with diabetes is very active? Huh. This is not a conditional problem. Oh, maybe it is. Okay, so I'm sorry. So this one is. I was misreading it. I was like, well, that doesn't make sense. So the thing that the like in the previous problem here. Let me try to make a point here. Um, the deadly. See how this deadly part that tells you like what goes on your bottom level. So the first thing tells you that. So here it's what's the probability that a middle-aged man. So uh, the is very active. So we've got like that kind of tells you your branching here. We have like active and not active. And we're starting out with a middle-aged person. So 1/4 are very active, and the rest are not. Okay. So for those that were active, a third is likely to develop diabetes as compared with men who were sedentary. So that's a little weird. So it's like this. It's like here's whatever this number is over here. I'll call this X. This is 1/3 of X. Okay, and you might think, well, how does that help? Well, they kind of tell you that they tell you that 202 out of 5,990 got the diabetes, and like this 1/3 x plus x has to equal 202. Because that's these two numbers added together has to equal this fraction. Because we're trying to get some numbers that work together. So because these two numbers have to equal this whole number here. So we got 1/3 x plus x equals this here. So we have 4/3 x equals 202 over 590 or 5990. So let me get that. Times. Okay, so x ends up being 0.0253. And then 1/3 x is going to be a third of that number to get it. So let's do one third of that. So that's so this ends up being 0.0084. All right. Now, so this is the fact that get diabetes, and the other one would be not diabetes. So now the what they're asking about in this question says, what is the probability that a middle-aged man with diabetes is very active? So they have to have diabetes, so it's going down these roads, but we want the one that says that they're very active. So this one on the left is 1/4 times 0.0084 plus 3/4 times the 0.0253, but we want this first one because they're the active. Just entering this into the calculator. So I end up getting, I really hope this is correct, 0.0996.
That's what I got.
Great. I hadn't seen one like this in a while where they don't give you the probability, they just give you these ratios. I didn't like that. Okay. Okay, let me search for these. Well, they do this problem very differently. So, all right. Well, let me try again here. We'll try to make this, give us another shot. They don't, the way we did it should have worked, but it didn't seem to work out with the right number. So let me get this. So, all right. So it says that we're supposed to assume that 1/4 of all middle-aged men are active, and the probability of being active is equal to A times the population. So that's A times 1/4, which is A over 4. And then it says that sedentary men is 1 is 1 minus the this 1/3, 1/3 here. So then ends up being 2/3. Okay, but then it says that the probability of being sedentary and developing diabetes. This is what I don't follow with the solution here. It says it's 2 times A times the 2/3. So that gives you the 4/3. I mean, we kind of had a 4/3 previously, but uh, so uh, so this is like going down. We have these forks here. Um, this one that we want is down here, and then this other one. Sorry, there's an A here. Is 4/3 A over here. So it's just like we did before. You take the both of them on the bottom, A over 4 plus 4/3 A, and then the one that you want is up top. Now, because there's an A in all of them, they cancel. So it's 1/4 over 1/4 plus 4/3. And that is the probability according to this solution here. So let me just see if I can get this 0.25 plus 4/3. So I end up getting 0.1579, 0.1579. Didn't like that either. Well, yeah, maybe we'll maybe ask your instructor on this one what to do here. I know there's not a ton of time, but let me. Well, maybe we'll have time. Right? Let me move to the last one though, because unless you want me to spend more time trying to figure this one out.
No, it's okay. We can just do the last one and then yeah, because I have class at 3 anyways, so.
Okay.
I'm happy to end early.
Yeah, there's always ways for me to get the answer, but not explain it well. And that's sometimes when I say ask your instructor, because I'm feeling like they're going to say the same thing, like, oh, this won't be on your test. So, all right. According to a study, no, another one, child seated in the front seat who was not wearing a seatbelt was 81% more likely to be killed in an accident if the car had an airbag that deployed than if it did not. Airbags deployed in 28% of all accidents. For a child seated in the front seat not wearing a seatbelt, what is the probability that the airbag deployed in an accident in which the child was killed? Okay, so we have child killed or not, and sorry, maybe we start with the airbag here. So airbags are deployed in 28% of all accidents. Okay, so we have an accident and we have an airbag, and 0.28 yes and no 0.72. If they were not wearing a seatbelt, they were 81% more likely to be killed in the accident if the car had an airbag than if it did not. Okay, so this is one of those, again, like whatever the number. Okay, so they weren't wearing, and they died. Okay, it's saying whatever this number is. I'm sorry, 81% more likely to be killed in an accident if the car had an airbag. If the car had an airbag that deployed than if it did not. Okay, sorry, this is a little awkward. Yeah, so this hint down here at the bottom is very helpful. This 1.81 times. So I just got to get the right, because it reads awkwardly. It's like if the airbag deployed, they were more likely to die. So this is X, and this is 1.81X. So if they go down this path of and maybe that's what we did wrong on the previous one. It was, well, that's probably why they doubled it. Anyway, Okay, so if they're not wearing an airbag, they have some probability of dying X. If they are wearing an airbag, it's 1.81 times as likely. So that's why it's there. So we now go down these paths here. We have 0.28 times 1.81, 1.81x plus 0.72 times x, and the one we care about was probably that the airbag deployed. So that's that. It's this other path here. This 0.28 times 1.81 x. Now there's an x in all these, so you just ignore the x. You can just either factor it out or just ignore it. So it becomes 0.28 times 1.81 over 0.28 times 1.81 plus 0.72. Let's try that and then see if we can get 28 times 1.81. All right, so I get, when I do that, I get 0.4131. So we'll try that. Okay, that did work. So let's maybe look at this previous one and give it another shot here. All right, so 1/4 of all middle-aged men are active. That means 3/4 are not active. And assume that a third were as likely to develop diabetes as compared with men who were sedentary. Okay, so let's do this. Get rid of this stuff. That's not what I wanted. Okay, let's see if we can just get that. No. All right, let me grab this question again. It'll be a little easier. You can just tell me when you need to cut out if we have a little bit of time here to finish this off. Okay, so active and not active. So we know that 1/4 of all middle-aged men are active. So 1/4 and 3/4. Third is likely to diabetes as compared with men who are sedentary. Okay. So we care about, did you get diabetes? Did you get diabetes? So the way it reads again is that you were third as likely to develop a diabetes compared with men who were sedentary. So if you're not active, you have some probability of getting diabetes. And then this is 1/3 of that. So we're gonna do the same thing we did in the previous problem. We're gonna go down both of these paths. So it's 1/4 times 1/3 x plus 3/4 times x. And then which path do we care about? Well, we care about the one that says um, whether they're active. So this one on the left here, 1/4 times 1/3 x. So since they all have an x, the x's cancel. So you have 1/4 times 1/3 over 1/4 times 1/3 plus 3/4. Okay, so let me try that. That looks a lot better to me. Looks like it might have been, I don't know what kind of error in the previous one. So this one says it ends up being 0.1. So we'll try that. Actually worked out pretty nicely. And that does it. So if it were me, I'd probably want a little more explanation on 7 and 8. Maybe from your instructor, see if they're going to be on the
Okay.
test. They're definitely the more difficult ones of these.
Okay.
But that takes care of all of the questions in this assignment.
Okay.
Would you like to stop here?
Yes.
Excellent. I will send out the notes and the screen recording here shortly. Thank you.
Thank you.
Bye now.